Hello everybody. Today's video covers lesson 7-3, Similarity and Transformations. Today's video and assignment, which is on page 540, numbers 1 through 3, you're really trying to figure out, are the shapes similar, and if so, what kind of transformations are being made to it? And just as a reminder, transformations are reflections, translations, rotations, dilations, right? We are trying to see if any of those transformations are happening to these shapes. Now, to figure out if the shapes are similar, we have to use ratios, common ratios. If the ratios are not proportional, then the shapes are not similar. So, for example, on number 1, we have to figure out if the two figures are similar by using transformations and explain your reasoning. So first, I want to take a look at this and I want to say, okay, are the shapes similar by a ratio or by a proportion? So if I'm dealing with a rectangle, I can use length and width, right? So we could use length and width. And or if I'm using some other shape, most of the time I'll use base and height for my ratio or my proportion. So as I'm making these, what I'm going to do is I'm actually going to make fractions using the length and the width. So I'm going to use length divided by width for my ratio. So for ABCD, rectangle ABCD, the ratio from the length to the width is going to be, well, the width I know is 2, and I'm going to say that the length is 5, right? So 5 over 2, which is 2.5, okay? So now looking at rectangle EFGH, I have to see, okay, length to width. What's my length? Well, my length is 1, 2, 3, 4, 5, 6, 7, and my width is 3. But 7 divided by 3 does not give me 2.5, right? It would be nice if it did, but in fact, 7 divided by 3 gives me 2.3 repeating, or 2 and 1/3. Okay, so we could say that are the triangle, I mean, we don't have to worry about a transformation here. We know it is not similar because the ratios are not equal. The ratios, we could say 5 over 2 does not equal 7 over 3. Okay, and that's a way we could kind of describe that shape. We could say, okay, it's not similar because of this. Okay, so hopefully that makes sense, and will kind of help you out with number 2. So like on number 2, we have triangles now. So we're not going to be using length and width. We're going to be using base and height. So remember, on a triangle, base and height are these sides that make up the right angle. So let's find the right angle, which is here. The right angle of triangle DEF, we'll go base to height. The base is 3, and the height is also 3, which 3 over 3 equals 1. So triangle DEF has a ratio 3 over 3, which is 1. Triangle ABC is going to have a ratio base. Now, we have to be careful because the base here is going to be BC, right? So my base over height, base is going to be 1, 2, 3, 4, 5, 6. And my height in this case is also going to be 1, 2, 3, 4, 5, 6. And 6 over 6 is 1. So we would say, yes, they are similar. But how? Okay, they do have the same scale factor, or sorry, they do have the same ratio. So we got to figure out what the scale factor is. So how do I get from a side length or a base of 3 to a base of 6? Well, we multiply by what? By 2. That means this shape has a dilation. And what else happens? How do I get from this blue shape to the green shape? Well, I can reflect it, right? If I reflect this shape, it is going to match on top of this shape. Okay, so I could say a reflection and a dilation of now, if we're going from DEF to ABC, then it's going to be a dilation of 2. If we were going from ABC to DEF, it would be 1/2, right? So I hope you can see the difference there. Since I went from DEF to ABC, we're going to say it had a dilation of 2, okay? But if you went from ABC to DEF, you would just need to explain that, okay? So we would say in a dilation of 2 for triangle DEF to triangle ABC, right? I'm telling which way I'm mapping. That way I know for sure which sides I'm multiplying by to get to my final result. And my last one is a word problem here. It says a t-shirt iron-on measures 2 inches by 1 inch. And if you want to, just go ahead and draw a shape here, 2 by 1. It is enlarged by a scale factor of 3 for the back of the t-shirt. So if it's enlarged by a scale factor of 3, we just got to multiply everything by 3, right? So now my new shape is going to be 6 by 3. And then it's enlarged by a scale factor of 2. So now we got to multiply this shape by 2. So this is going to be 12 by 6. So it says, what are the dimensions of the largest iron-on? Well, the largest dimensions are 12 inches by 6 inches. And it says, what are the are both of the enlarged iron-ons similar to the original? Well, how do I get from 2,1 to 3 or 6,3? Well, I can multiply by 3, so those two are similar. How do I get from 2,1 to 12,6? Well, I can multiply those by 6. So yes, they are both similar. Okay, and it doesn't ask us to explain here, but I could. I could say from 2 to 1 to 6 to 3 has a scale factor of 3. And then 2 to 1 to 12 to 6 has a scale factor of 6, right? Because if I multiply both of those by 6, that's how I can get to my last rectangle. Okay, so I hope that kind of makes sense. I hope that's beneficial in some way. If you have any questions, please feel free to email me. Also, I have the Zoom office hours twice a week. Please check those out. Come talk to me. I'm willing to answer any questions you have. You guys are doing a great job. Please keep working hard. We're almost there. We're getting to our final finish line for the year, and I just commend you for all your hard work you've been doing. So thanks for watching, and I hope you have a great day. Thanks.